So let's do a recap with lines. So recap on lines. First things first, what is the equation of a line? Does anybody know the equation of a line? These are two people here, so either one of you all. What is the equation of a line?
Equals mx plus c.
Right, y is equal to mx plus c. Caleb, what does m stand for?
Um, I remember this one.
Right, so m stands for the gradient. Do you remember the formula for the gradient?
Y2 minus Y1
Excellent. So changing y over the
over X2 minus Y1.
right. What does c stand for?
Uh,
That's the y what? The y what?
Y step
Right, the y-intercept. And at the y-intercept, what do we know? We know that the x value is equal to what?
0.
Yeah, correct. Awesome. Now, if I have two parallel lines, so Caleb, if I have two parallel lines, what we know about the gradient for both of the lines?
Um,
So can we both agree that parallel lines both travel in the same direction? They just don't touch each other?
that's it.
Yeah, so the thing about parallel lines is that they have the same gradient. Lines that have the same gradient, but Serena, they would have the same gradient, but what would they not have in common? Serena?
They will have the same y-intercept.
Exactly, they wouldn't. Because if I were to draw the y-axis over here, are both of them cutting the y-axis at the same point?
No c.
Nah. So they have the same gradient, but different y-intercepts. So you need to know that for parallel lines. And let's come down to perpendicular lines now. Do any of you guys remember what perpendicular means?
That's it.
It means it cuts at a 90-degree angle.
Excellent. So if I had this line here, then Caleb, perpendicular. So okay, we could call this L1, that's line 1, right? And this would be line 2. Caleb, what do you notice about the angle between these two lines? The angle between those two lines. What angle does this look like?
9. See?
Yeah, 90 degrees. So if two lines are perpendicular, then the angle between them is 90 degrees. Understand? Understand?
Yes.
Right. And let me show you another property of perpendicular lines. If the gradient, let me take a matter. Let's just say that the gradient for line 2, M2, was equal to, it was equal to 7. Then the gradient of line 1 would be equal to what? Do you remember, Serena?
It would be the negative reciprocal, so -1/7.
Yep, it would be negative 1 over 7. So I'll make a little note about that to the side. So the gradient of perpendicular lines are the negative reciprocal of each other. Right, so Caleb, I guess then you didn't know this. Or did you know this? Talk to me.
Nothing.
Nah? Okay. Well, it's a good thing you learn about it now. So we have a line 2 here, and we have a line 1. So Caleb, and you saw that the angle between these two lines was 90 degrees?
Yes.
Great. So if two lines are perpendicular to each other, meaning they are at a right angle to each other, then the gradients are going to be the negative reciprocal of each other. You know what the word reciprocal means?
I when you flip it.
Yep, that's when you flip it. So long story short, if two lines are perpendicular and you want to find the gradient of the other line, given one line, you're gonna take the gradient of like okay. So Caleb, to make this make sense fair, let's just say you were given the gradient as 7. Isn't 7 the same thing as 7 over 1?
Yes, sir.
Okay, I want you to flip that from up. Flip it from up. If you flip it, what would you get?
One over 7.
Right, and change the sign.
Minus 1 over 7.
That is all. So if two lines are perpendicular to each other and you have the gradient of one of the lines, then to find the gradient of the other line, you're going to flip it and change the sign. Understand?
Yes, sir.
Great. So copy this down and let me just make a little note here. Just draw a little diagram. As much as I say I will use old notes, I just can't do it, guys. I just can't do it. I just feel so lazy. Like I feel like little learning has happened if I just reuse the same notes over and over. Yeah. So Caleb, you see where the line is cut in the y-axis over here? You seeing that or no?
Yes, sir.
Yeah, that is what we call the y-intercept. That's the c value. That's the c value. And if I want to find the gradient will just be the change in y over the change in x. So maybe you might take this point over here, and maybe you might take this point over here. You'll call this point x1, y1. You'll call this point x2, y2. Diagrammatically, it would look like this. Right, Caleb? What would this correspond to? This length over here, would that correspond to x2 minus x1? Or do you think that would correspond to y2 minus y1?
X2 minus.
Now look at it carefully. Look at it carefully. So Caleb,
X1 minus X2.
now, if this is x2, comma y2, right? This would be x2, and this would be what? What would this be?
Y2.
This would be y2. If this is x1, y1, this would be x1, and this would be y1. So when you find this, you're really finding for what? Let me help you out. That'll be y2 minus y1. Because you're
Yes.
finding the space in the middle. So that'll just be y2 minus y1. What do you think this would be?
X2 minus X1.
Exactly, because this would be x2, and this would be x1, and you're finding the space in the middle. They probably don't teach you that in school, but when you find an gradient, that's what you're actually doing. So that's why they say change in y over change in x. So the gradient is just equal to y2 minus y1 all over x2 minus x1. All right, so if you need to, take a screenshot of these things, and we'll move on to some other things that you need to know. All right, so just confirm that you all took our screenshots. Confirm?
Yes, sir.
All right. Serena, everything that I'm showing you here so far is things that you knew, right?
Yes, sir.
I bet. So let's move on to some things I perhaps you did not know. What about midpoint? This comes a lot, midpoint in hard maths. Let's just say you had these 2 points over here. So you have a point A and you have a point B. Let's just call this point x1, comma y1. And what do you think I'll call this point?
X2,
X2.
Y2.
Yeah, x2, comma y2. Now, as the name suggests, if I say midpoint, where do you think the midpoint would be?
In the middle?
Exactly, in the middle, right? So that's going to be over here. Now, how exactly do you think I'll find the midpoint? When we think middle and we think of dividing by like cutting something in half,
Yes.
yeah. So you know what we could do? This is real simple, you know. It's real simple. You're just gonna add x1 and x2. You're gonna divide that by 2. And what do you think you're gonna do to find the y value?
Y1 and Y2 divide by 2.
Exactly. It's very straightforward. So, Serena, some intuition behind this. Okay, so Serena, do you understand that from here to here, that would be the difference between x1 and x2. Yeah?
Could
So
you
like,
repeat that, sir?
think about it. This is just some intuition behind it. If this is x1, y1, wouldn't this be x1 here if it was on the x-axis?
Yes, sir.
And this would be x2 over here. And this would be the distance between it, right?
Yes, sir.
Well, the midpoint would be located in the middle. So another way you could do it, you could just add x1 and you could add x2, right? And the midpoints will be found in the middle. Think about it. If I told you that this was, say, 5 and this was 10, how would you find the point in the middle?
You would add 5 on 10 and then divide by 2.
Exactly. So that makes sense, right? The intuition makes sense. And Caleb, let's try to understand something. So Caleb, if again this is x1, y1, so imagine this is the y-axis over here, and this is the x-axis over here. So Caleb, what would this correspond to on the y-axis?
Y.
Y, y2,
Y1. Yeah.
right? Y1. And what would this correspond to here?
Y2.
Right. So if you know what y1 is, and if you know what y2 is, and to find the middle, and you would just add y1 and y2 and divide it by 2 to figure out.
Yes.
That is all. So I hope we're not lost by this. I think this is easy. Right, so that is the midpoint. The next thing you need to look at, you need to be able to figure out the perpendicular bisector. So Caleb, you should know what perpendicular means by now, right? Perpendicular means that the lines are cutting each other at a what angle? Anytime you hear perpendicular, Caleb, what angle should come to mind? And I hear in Caleb, but Serena, Summer, if I say the word perpendicular, comes to
Could
mind.
you repeat that, sir? It
If
was
I
sticking
say
on my end.
if I say the word perpendicular, what angle comes to mind?
90 degrees.
90 degrees, right? And when you hear the word bisector, you think that you're doing what?
But you cut in the 90 degrees.
Not quite.
Mm,
Cut
was it?
bisector just means cutting something in half, right? So perpendicular means 90 degrees too. And bisector means cutting in half. So let me show you what this perpendicular bisector thing is about. So let's just say you had a line segment. This is A, and we're going to B. And we could call this line 1. Do you understand that? All right, so look at this, right? Can you, okay, where does the green line cut the blue line? It cuts it at the what point?
The midpoint.
Exactly, that's number 1. If we are looking at the perpendicular bisector, remember, bisector means it cutting it in half. So that green line, which is the perpendicular bisector, is going to cut line 1, the line segment AB, is going to pass through the midpoint. It's going to cut it at the midpoint because it's cutting it into 2 equal halves. And the other thing is, the angle here is supposed to be 90 degrees, right? And this is line 2. So anytime you're doing a perpendicular bisector question, 2 things should come to mind. Number 1, I need to find the midpoint, right? I need to find the midpoint. And the other thing that should come to mind is, Caleb, what did I say about perpendicular lines? There was a relationship. If lines are perpendicular, how are the gradients related to each other?
They are the same gradient.
Nah, perpendicular, perpendicular, perpendicular. Parallel lines have the same gradient because they're going in the same direction. But that's not the case for perpendicular. What did I say about perpendicular lines? Give that a read from.
The negative reciprocal of each other.
Exactly. So anytime they ask you to calculate the perpendicular bisector, immediately you need to find the midpoint. And the other thing you should probably be trying to figure out is, what is the gradient? Okay, if they give you the gradient of one of the lines, then you just have to change the sign and flip it, and you'll get the gradient of the other line. So the other thing that should come to mind is, the gradient of perpendicular lines are the negative reciprocal of each other. So what are we waiting for? Let's jump straight into that question. So take a screenshot of midpoint and take a screenshot of, well, it'll be one screenshot. Take a screenshot of that and we'll try a question.
I get the screenshots. Sir.
I'd say no more. Serena, you okay with everything?
Yes, sir.
All right, question time. Let's go. Serena, I feel like you know how to do this question. So I'm going to give Caleb a chance. Right. So Caleb,
Yes, sir.
I want you to read the question for me.
Write the equation of the perpendicular bisector of the segment with endpoints 5, comma, minus 8 and minus 2 and 3.
All right. So Caleb, let's try to examine the question, right? So they want us to find the equation of the what? The equation of the what?
Perpendicular bisector.
Right. Now, do you remember what perpendicular bisector is?
The 90 degrees through and cutting in half.
Yeah. So the perpendicular bisector is the line that passes through the midpoint of another line, 90 degrees straight. Right. And the segment we are dealing with is 5 comma minus 8 and minus 213. So Caleb, I'm just going to do a quick sketch, right? None of this is entirely accurate. I'm just going to do a quick sketch. Quick sketch. So let me just say that this is 5 comma minus 8. Again, all of this is a sketch. It's not entirely correct. It's just a sketch. And let's just say that this is minus 2 comma 30. Yeah?
Yes, sir.
Now that's just a sketch, right? That is not how it will actually look like, but because these points probably wouldn't be there. But like, let me know if you understand the concept. I cannot go aiming for.
Yes, sir.
All right. Are you able to draw on the screen?
I think so.
All right. So I want you to try and figure out what the perpendicular bisector would look like for that line segment.
So you can see that, sir?
So what you're doing there is not correct, eh? I mean, for that example, yeah. But Caleb, if I draw this line segment over here, this is what I drew. I want you to draw the perpendicular bisector for this line specifically. Show me what the perpendicular bisector for that line would look like.
The midpoint, you have to find the midpoint, that's it.
Just draw a sketch. So where do you think the midpoint for this would be?
Right. Probably here.
Yeah, I would say over there as well, right? So the line that you draw, it needs to pass through this line and it needs to be at a what angle?
90 degrees.
So show me what that would look like. I'm not seeing anything. Okay, that would not correct because that angle there, that angle does not look like 90 degrees. That wouldn't be correct. It would be like this.
Yes.
Yeah. But I think you had the idea. Right? So this is going to be the midpoint. We need the midpoint for sure. That's a major thing. Right? And my perpendicular bisector is gonna look like this. Now, Caleb, let's try to think, right?
Yes.
Do you remember how you could find the midpoint?
Yes, sir.
All right, tell me, how am I gonna find the midpoint?
X1 and X2 over 2.
So which one you want to label X1 and Y1 and whatnot?
For the 5 and minus 8, X1 and Y1,
All right. Mm-hmm.
and the minus 2 and 13, X2 and Y2.
Right. All right. Yeah. So
Yeah.
if you put it into this formula, what would that look like?
5 and minus 2 over 2.
Right. So that'll be 5 plus minus 2, which is really just 5 minus 2. Yeah. That'll be 5
Yes.
minus 2 all over 2. Mm-hmm.
And minus 8 plus 13 all over 2.
Right. So where's 5 minus 2?
3.
Where's 3 over 2 is
1.5, 1/2.
by 1.5. What is minus 8 plus 13?
5,
Right? Where's 5 over 2?
2.5.
Right. Awesome. So tell me, Caleb, do we now have a point that the perpendicular bisector passes through?
Yes, sir.
And just see enough for yourself, right? Like that line passing through that point. Great. Now, the other thing we would need to do, we would need to figure out the gradient of the perpendicular bisector. Now, before I could do that, would it be possible for me to find the gradient of this line?
Yes, sir.
Okay. And once I have the gradient of the blue line, how am I going to use that to figure out the gradient of the red line?
Flip it and put it in the negative.
Well, not turn it negative, but change the sign. That's it.
Change this sign, yeah.
So let's find the gradient of the line segment. Right? So gradient of line segment, right? Which is just m. That is going to be equal to y2 minus y1 all over x2 minus x1. We have already labeled. So you tell me what to write.
13 minus negative 8 minus 2 minus 5.
Right, so let me just verify that. So y2 minus y1, then x2 minus, yeah. So what is minus by minus?
Positive. So 18. So
Now, what is 13 plus 8? Wouldn't be 18.
22.
Nah, don't 22.
21
21, yeah. All right, what is minus 2 minus 5?
minus 3
Nah, imagine you take $2 and then you take $5 again. How much money you take altogether?
minus 7
Yeah. All right, so we have a positive 21 divided by a negative. What's a positive divided by a negative?
and negative
Yeah, negative, right? And 7 into 21 is,
minus 3
oh, 3, right? So it'll be a minus because it's a positive divided by a negative. So negative 3. So that is the gradient of the line segment. You okay with that?
Yes, sir.
Now, if the gradient of the line segment is minus 3, how could we use that to find the gradient of the perpendicular bisector?
Um, minus 1 over 3.
Nah,
3 over 1 side.
nah. So let me take my time, right? First things first. This is the same thing as minus 3 over 1, right? So you wanna flip it first. So it's now gonna turn into minus 1 over 3. Yeah.
Yes, sir.
Then you wanna do what next? So it's not making a negative, right? You're changing the sign.
Positive 1 over 3.
Yeah, that is what I want to hear. Positive 1 over 3. So Serena, I presume you get through this?
Yes, sir.
I bet. So, Caleb, we have plenty information now, real information. We know what the gradient of the perpendicular bisector is, and we also have the what?
Endpoints.
We have the midpoint, right?
Oh, yes.
Why is the midpoint important? Caleb, didn't they want us to find the equation of the perpendicular bisector, which is the red line?
Yes.
So if you want me to do that, then we need to figure out the gradient of the line, and we need to figure out a point on the line. So anytime you're dealing with lines, you need to figure out two things. You need to figure out the gradient. That's one thing. And you need to figure out a point on the line. Point on the line. Do we have all of those things for the perpendicular bisector, which is the red line?
Yes.
Great. So now we could use the equation of a line formula. What is the equation of a line?
Y equals mx plus c.
Right. Y is equal to mx plus c. Awesome. Can you remind me what points we had on the line?
1.5.
Right? The point we had on the line was 1.5, comma.
2.5.
Right. So what do you think the x value is?
1.5.
Right? And the y value is 2.5. Great. And what is the gradient?
1/3.
Yeah, 1/3. So I can now plug all of this into this equation, and what will I find for now? If I know what y, x, and m is, what am I going to find for?
C.
I'm going to find for c. And what does c stand for again?
Y intersect.
Bets. So y is 2.5.
1/3.
Right? I'm going to multiply that by x. X is 1.5 plus c. Now, this is why I tell students, so can I keep it in terms of fractions now? This is why. But it will still work out. Let's plug it into our calculator. So what is a third of 1.5? It is a half.
Yes.
So you have 2.5 is equal to a half, which is
That's
0.5
C.
plus c. So how would you make c the subject of the formula now?
For the 2.5. Well, put the C on the. Put the 2.5 on the other side. And what do you see?
Say that again?
Put the 2.5 on the other side of the equal sign.
Not quite. To kill up. C is the unknown here. We're trying to make C the subject of the formula. So we want C to be by itself. We don't really care where C is once it by itself, once it's lonely, once it's sad, once it total, once it have no Valentines on Valentine.
So put 0.5 on the other side.
Right. C real single. C sad. You see tomorrow, C gonna be crying. Kill up, you have a Valentine's for tomorrow.
Yes, sir.
Way boop boop big up you. Serena, you have a Valentine's for tomorrow?
No, sir.
No, okay. All right. So that's gonna be 2.5 minus 0.5.
2.
Yeah, so C is equal to 2. So let's put everything together now. All right, so my final answer is going to be Y is equal to what? What is M?
1/3.
Yeah, X.
Bracket 1.0.
Nah, yeah,
Plus
Caleb,
2.
the only reason why we needed a point on the line was to figure out for C. In
Yes.
the equation of a line, you need to put the gradient and you need to put the y-intercept. You will leave y and x blank because it's a function. You could plug a x value in and you'll get a y value out. So it's going to be a
Yes.
third x and the c value.
Plus 2.
Yeah. I'm wondering if you're okay with that.
Yes.
Awesome. Bet. So Serena, you had everything?
Yes, sir.
All right. Let me show you an alternative way you could have done it. So you see this form over here? I don't know they tell you the form in school, but this is referred to as the and Serena, let me show you how you can figure this out, right? Isn't M the gradient?
Yes.
M is the gradient.
Yes, sir.
And another word for gradient is slope, right? Slope. And C is the what?
Y-intercept.
Y-intercept, right? So this form is actually called the slope intercept form. Do you know that, Serena?
Yes, sir.
Well, now you know, right? And there's another form though. There's the slope point form. Yeah, do you know the slope point form by chance?
No, sir.
No? Okay, don't worry. I'll show you it. Now, this method is fine, and this is why I would recommend you doing the exam. The other one is fine as well. It's just that you have to remember one more formula, and I don't think you want to remember one more formula. Yeah, so this is the other one. So y minus y1 is equal to m by x minus x1. Have you all ever saw that in school?
Nah, sure.
Okay, because when
No,
I
sir.
was in secondary school, my teacher had shown me this, and he used to do it like this. But when I started teaching, I was like, you know what? This is kind of easier. Because everybody remembers y is equal to mx plus c, right? Everybody knows y is equal to mx plus c, but you probably don't know this. Probably don't know that is y minus y1 is equal to m by x minus x1. And this is referred to as the what? Think about it, Serena. In this form, you have the what?
Y-intercept on the
Nah,
table.
not the y-intercept. The y-intercept is not here. The slope is
No.
there though. The slope is there. Caleb, haven't you seen m?
Yes, sir.
Yeah. So this is called the slope, but it's not the slope intercept form. The intercept is not here. Notice we have x1, y1. That would correspond to our what? Our what? That's what P.
Uh,
It's simpler than it looks. X1, comma y1. What does that stand for? Our what? P.
Point.
A point. So this is referred to as the slope point form. So let's see how this will work out. Now, to use this, again, it's the same concept. You need to know what the gradient is, and you need to know what the point, you need to know a point on the line. So Caleb, and we know the gradient is a third, and we know the point on the line is 1.5, 2.5.
yes, sir.
Right. So where x1 and y1 are um the values for a point on the line. So if we're using this formula, it's going to be y minus what? What is y1? Tell me, Caleb, what is y1? So x1 and y1 are just values for the point on the line. The point on the line is 1.5, 2.5. So what is what is y1? What is the y value?
Y1,
What was the y value for the point on the line?
can't remember, sir.
I right here in front of your eye. And right here. I promise it, right here.
1/3.
Nah, that's the gradient. I'm asking you for the values for the point on the line. Point on the line.
Or 2.5.
Right. That is 2.5. So it's y minus 2.5. And we know that the gradient is a third. And in brackets, you're going to put x minus x1. So x, and then x1 is just the x value, which is 1.5. Next thing you're going to do is you're going to expand the brackets. So a third by x is just a third x. And what is a third by minus 1.5? Tell me, Caleb, what is a third by minus 1.5?
Um, minus half.
Yeah, minus a half. And to get your answer now, all you had to do is just move across the minus 2.5. So y would be equal to a third x, right? Minus a half plus 2.5, which we know is just 2. So y is equal to a third x plus 2. Which method do you all prefer, the slope-intercept form or the slope point form?
Slope intercept.
Same.
Slope intercept.
I think that's that's the easier one, for sure. That one, I feel like it requires less brain power to remember. Because again, everybody knows y is equal to mx plus c. All are we know that. Yeah. All right, let me know if you're okay with this.
Yes.
All right, so
Yes, sir.
Caleb, if you want to find the equation of a line, what are the two things it must have?
Ingredient.
Yeah, you need the gradient and you need what else?
Point on the line.
Exactly. Once you have that, you're fine. You're fine. And Serena, I presume like this is like baby stuff here. Like this is lightweight stuff. Like this is not even scratching your brain.
Yes, sir.
Okay. All right, cool. Let's do I'm going to give you all a question to do for me. All right, give that question a try for me, and then we'll move on to we need to look at we need to look at I will look at intersecting lines briefly. Actually, never mind. I'll do that when I do the circles. I will show you guys how to find the length of our line, the length of our line. But copy. Yes, so good luck, muchachos. Good luck, good luck. I'm going to give you all 4 minutes in which you can attempt it. So, Serena, up to this point, we just do regular maths, right? This is just regular maths.
Yes, sir.
Cool. Okay, I have a question. Are you still seeing the screen?
It keeps like
I
disappearing
said
and coming back.
yes.
Are you seeing it or nah?
It was coming in and out too.
I was trying something. Yeah, I'm gonna do that. I should be seeing it now.
Yes, yes.
Okay, did any of you get through the question?
Yes, sir.
Yes.
Serena, yeah or no?
Yes, sir. I think so.
All right. Killer, what about you?
Nothing.
No. How come?
Harry just told us.
Hmm. All right. I will do the question together, Killer. That's okay. So I want you to read the question from a first. That's the first thing I want you to do. Give it a read from.
A line L passes through the point 6 and 5 and is perpendicular to a line whose equation is 3x plus 4y minus 7 equals 0. The equation of L is
Ah. So Caleb, what if I told you that this is easier than you think? Would you believe me or be like, nah?
um yes, sir.
All right. So long story short here, Caleb, we want to find the equation of our what?
Perpendicular
No. All right, to read back the question. So,
or L
right. We want to find the equation of our of L, but what is L? L is our what? L is our what? What is L?
a line passes through point 6 and 5.
Right. Imagine if this was instead of 5, it was 7. But anyways, um, The point is a line, right, Caleb? Is a line.
Yes.
To find the equation of any line, you need what? You need what two things? What two things do you need?
The gradient and the point.
You need a gradient
Um,
and you need the what? You need a point on the what?
the points on the line.
You need a point that falls on the line. Point on the line. And we want to find the equation of line L. That's what we want to find. I want you to read the question and tell me, do we have any pieces of the information here for L?
Yes, sir.
Which piece of information we have?
That it passes through points 6 and 5.
Right? Do we have a point on the line? That is extravagant news. All right, we have a 6,5. Now we need to find the gradient. Okay, so I'm just going to do a little sketch, right? Let's just say that this point was 6,5. And this line L, it passing through that. So these are sketch. These are sketch. This don't have to be accurate. It's just a sketch so you could visualize what happening. So you just see I draw a line here?
Yeah.
What should I call a line?
L.
I should call it L, right? And they're saying that line is what? What is saying about our line?
Passing through points 6 and 5.
Okay, we established that already. We know that. What else is saying about it?
It perpendicular to a line whose equation is 3x plus 4y minus 7 equals 0.
Aha, okay. If it is perpendicular to this line now, then the line I underline in red would be at a what angle to this line?
90 degrees.
Yes. So do you understand that the other line is going to be perpendicular to the line L?
Yes, sir.
You sure? We okay with that, right? You confident?
Yes, sir.
Okay, happy to hear that. Now, what do I know about the gradient for lines that are perpendicular to each other? What do I know about them?
The same.
Again, they're not the same. Let me ask you a question. Let me put something in your head. You're not gonna forget this. Do you actually know what gradient is? Be honest with
Yeah.
me. So, like, I have a question, right? So, gradient refers to the steepness. Imagine you're in a car and you're
Yes.
driving up a hill. So, let me ask you a question. If you're in this car, I don't know what kind of car is that. I'm gonna draw a proper car.
Mm.
Forget to draw, boy. Forget how to draw. What? Bro, let me just say you're in a car, right? There's a car.
Yes.
You're driving upwards and you're in a car here. Would both of the cars be traveling in the same distance? Like, would the experience be the same?
Uh,
Are they going in the exact same direction?
nah.
Are both of them the same steepness?
That's it.
No. So will they have the same gradients?
That's
No. Never, never, never. You're confusing that with parallel lines. But you see, the thing about parallel lines is watch. Are both of these cars going the same steepness? Like, are both of them going up a hill with the same steepness and the same direction?
yes, sir.
So then if it's parallel, then they have the same gradient. But if they are perpendicular, will they have the same gradient?
That's it.
No, they will not. What is the relationship? If the lines are perpendicular to each other, what is the relationship?
The gradient of the perpendicular lines are negative reciprocal of each other.
Now I want you to understand what I mean, right? Okay. So if I told you that the gradient of this line was a quarter, what the gradient of this line would I be?
Minus 4
Minus 4/1. Excellent. So my question for you is, right, Caleb? Did they give
Yes.
us any information about the perpendicular line? That's my question.
Yes, sir.
Right. What did they give us the equation of it?
Yes, sir.
What was the equation of it?
3x plus 4y minus 7 equals 0.
Now, when you look at that, it kind of confusing you, right? Because you're not accustomed seeing it like that. What is the form you're accustomed seeing? What form are you accustomed seeing for a line? What are you
Oh,
accustomed seeing?
x and y,
Now, equation of a line. Equation of a line. What equation you're accustomed seeing?
y equals mx plus c.
That's what you're accustomed seeing, right? And if it's in this form, what two things you could pick up on? What two things you can read off? If it's in this form, what two things can you read off?
M and c.
Exactly. Is this in this form?
No, c.
No, but can we rearrange this to make it in this form?
Yes, sir.
All we would have to do is make what the subject of the formula. What would we have to make the subject?
Make y subject.
Exactly, you make y the subject. And if you do that, let me see if you could figure it out, right? So based on all the hints I dropped for you, why do you think we're doing all of this?
Mm, no, c.
Say that again.
I, I don't know.
Now you know the thing, man. You know the thing. So Caleb, back to the drawing board, right? If they want us to find the equation of what? What do they want us to find the equation of?
L,
Right. And L is a what?
a line,
Is a line. Now to find the equation of a line, what two things do I need?
a gradient, and a point on the line.
Which one we have already?
The point on the line,
So what we need to figure out now.
the gradient,
Right. The gradient of the red line. Oh, sorry about that. The gradient of the red line or the gradient of the blue line?
the red,
The red, you sure about that? Look at I want you to be able to figure this out. So look at this and I want you to make sense of what you're seeing. Is the red line line L?
yes, sir.
Okay. What they say about line L? They said that line L what?
It's perpendicular to a line. Oh, so the blue ones,
Yeah. And another thing, that blue line passing through what point?
6 and 5.
Exactly. Great. So and you know these and you know that these two lines are what to each other. They're what to each other.
Perpendicular.
Yeah, we know that they are perpendicular to each other. So if I know the gradient of one of those lines, what I could do now?
Um, Find the reciprocal and change the sign.
And why are you doing that for? To find the gradient of the what?
The line L.
Exactly. That is it. That's it. Yeah, yeah, Caleb. So watch. Connect all the pieces together, right? We have a point already. The only thing we really need to find for is the gradient. Why do you think they would give you the equation of the perpendicular line? Well, if they give you the equation of this line, and you could make y the subject of the formula.
Yes.
If you make y the subject, we could find for we could pull out from that.
M, X, and Z. Well, M and Z.
What's the main thing you want to pull out though?
M.
Yeah, you want to pull out m, right? And we're gonna do that m value. Are you gonna use that as a gradient for line L? Or
Yes.
all right, is this line L?
No,
So can you use that gradient as a gradient for line L?
no.
No, but what could you do? What could you do? If the two lines perpendicular to each other, after you find the gradient of this line, what you could do? Come on, we want to find the
Find the reciprocal.
yeah, that is it. So here what? Take a chance again and try to finish the question. You know what to do now. You know what to do. You have it. In the meantime, though, Serena, let me give you another question. Yes, Serena, that's correct. One thing though, Serena, how do you know that 6-5, that both of the lines passing through 6-5? That's my question for you. How you know that?
Well, I didn't read the question properly. I thought it meant like it was perpendicular. Like that
Oh,
was the point, that it was perpendicular.
now you lose some points for that.
Okay.
If I was marking a paper, I'd take away some points for that. We're not give full marks.
Okay.
Gotta be careful.
Yes, sir.
Caleb, we believe in you, you know. Caleb, lock in, man. Lock in. You could do it. Yeah, so Serena, let me get another question in the meantime. So Caleb, right now, what are you doing? What is your objective right now? What are you trying to find for right now at the moment?
The reciprocal.
But you had to get the gradient first. How are you going to get the gradient at the red line?
Um,
That's the question you should ask yourself. How am I going to get
y
right? So Caleb, what did they give us for the red line?
3x plus 4y
All right,
minus 7 equals 0.
right? They gave us that. Now this kind of unhelpful. Like we can't really do anything with that. What form are you accustomed seeing for a line? Like what is the form you're accustomed seeing for a line?
Y equals mx plus c.
And if it's in this form, like it told me, if it's in this form, what you can read off,
M and c.
right? You can read off the gradient. So what do you think you should do with this form? Right now it kind of useless to us. But what we could do with it to make it useful.
Make y the subject.
Exactly. Make y the subject and then you could read off what from it. You could pull out from it.
M is 3.
You could pull out m. Remember, Caleb, the main thing you were trying to find for is the gradient, you know. Because to find the equation of a line, you need the gradients. So that's the main thing you want to figure out. After you patent it from y is equal mx plus c, you need to figure out what m is. And then you need to find the negative reciprocal to find the actual gradient at line L. So Caleb, what is your main mission right now? Your main mission should be what?
Find m.
Right, but before you could find for m, you need to do what with this?
Make y the subject.
Right, so that is your main mission right now. You had to make that the subject. Right, Serena, the question that I gave you, how is it coming along?
It's again, my son in my weekend now.
Serena, you too good. I don't know what to say about you, yes. I feel like you wanna come to my pure maths class or what? I feel like that would challenge you. And I'd be like, what is
Yeah,
yeah, okay. That's 8 o'clock tonight.
okay. Let's give her.
Oh, I wanted to give you an equation, right? So like whatever boyfriend you get, if they don't know how to expand, okay, let me just give you some checks you should do, right? First thing, I want you to sit down. If you have a crush on somebody or something, you're gonna sit down with them and ask them if they could expand it. This is like the first thing you should do. Like if they say x squared plus y squared, I feel that thing. No, don't do it, boy. And the next thing, I'm gonna make a TikTok video giving people an equation to solve, and when you solve it, it will read one something like that.
Oh,
I'm gonna make an equation. If they can't solve that, that is it. No. That not for you.
okay.
I'll post that video on TikTok. I'll do it later tonight and I'll post it. Yeah,
Easy.
yeah. All right, so Caleb, did you make y the subject of the formula?
I think so.
All right. Talk to me. How would you make y the subject of the formula? Run me through these steps.
Um, 4i equals 3x plus 7 equal minus 7.
Nah, take your time, right? So you want to make y the subject. So you want the y term to be by itself. Right now, the y term is not by itself. It have a 3x there and it have a 7 over there. So you tell them to move it across. But if you move across something, you have to do what with the sign.
Minus 4i.
Now the signs would change. So
Oh,
like
yeah.
that 3x gonna turn to what?
Minus 3x
And what else?
plus 7
Ah. So now I have 4y, but I want to find for 1y. So what would I need to do with 4y?
divided.
And if I do something in one place, well, I need to do it everywhere. So I'm going to divide every single term by 4. So I'm going to end up with y is equal to what?
I equals minus 3/4.
Yeah, minus 3/4 x plus 7 over 4. Now, is this helpful to us? Is this form helpful?
Yes,
Because now we could actually read off from that. I mean, what's the main thing we're interested in?
the
The what? You have it, you have it. The what?
gradient
Yeah, the gradient. So if you're comparing this, okay, if you're comparing this and this, what is the gradient?
minus 3/4.
Right. But is that the gradient of L? Let's look back. Let's look back carefully, right? So this is a red line, right? And this is line L.
No, that the gradient like the red one.
Right, that's the gradient of the perpendicular line. So how am I going to use the gradient of the perpendicular line to figure out the gradient of the blue line?
4/3.
That is all. Yes, you have it. Big up you. All right. So the gradient for the blue line is going to be 4/3. You just flip it and you change the sign. So now you have the missing pieces of the puzzle. You had the gradient, check, and you have the point. What to do now? Tell Killer, you have it. So you have the gradient and you have a point. What to do now?
Find 4y's.
Now you need to find what, okay, so you have gradient, which is m, and you have a x and a y values. What is the only thing you're missing?
C value.
Right, so you need to use y is equal to mx plus c now to find for the c value. And then you could write the final thing. So um so tell me, what is the y value
5
and what is the gradient?
equals 4/3.
What is the x value?
6.
All right, great. What is 4/3 by 6?
Um,
So 3 into 6 is what? 3 could go into 6 how much times?
2 times 8.
8. Yeah, 8. Then you would want to move across the 8 to leave c by itself. So you can end up with what?
5 minus 8 minus 3 equals C.
Exactly, c is equal to -3. So now you can write the final equation. So what's the final equation?
Um, y equals 4/3 x plus, well, minus 3.
Yep, that's it. Was it that hard?
Nothing.
And like I say, it's not that hard. Like just look at what you need and you can figure it out. So like in the question, they want to find the equation of a line. So you need to figure out the gradient of line L, and you already know it passing through 6, 5. So and they give you another line, but the other line perpendicular to it. They give it in a kind of inconvenient form. So you should probably put it in the form y is equal mx plus c so you could actually figure out what the gradient is. But any gradients are any red line and the blue line are different lines. You see that? They're different lines, right?
Yes, sir.
So after you find the gradient of the red line, you change the sign and you flip it to get the gradient of the blue line. Once you have that, you just put it into y is equal mx plus c, and you find for c, and that is the day. Right. Cool. Right. So I will give you all some homework. I'm gonna end this class a little early because I have some things to do at home. Right? But I will give you all some homework. And one more thing before we go, we need to look at how to find the length of a line. That often comes. And I think I would have prepared you guys good going into circles. All right. So you need to know what the length of a line is. Formula for length of a line. Length of a line. So the formula for length of a line is just the square root of x2 minus x1 squared plus y2 minus y1 squared. Extra points if you could figure out where this comes from. Does anybody know? Did any of you all do trigonometry yet in school?
Yes.
Killer, where that come from? You know?
Um, yes, sir.
Serena, what about you? You know?
I'm not sure, sir.
You ever do Pythagoras theorem?
Yeah, I did.
Yeah, this is Pythagoras theorem. Let me show you why I say that.
Oh,
Watch this, right? Yeah, 1 second. Let me show you something, right? So, Caleb,
Yes, sir.
let me just say I had a point over here. Could you tell me what the coordinate for that point would be?
2,2.
Right? And what about this point over here?
7,4.
So then that line segment will be this over here, yeah? And then will be this over here.
Yes, sir.
Right. Now let me show you something, right? Check this out. What shape does that form?
Triangle.
Not just any triangle.
Right angle triangle.
Right. Now pay close attention to something. If I wanted to figure out this dimension, what would I do?
Um,
Hmm.
X.
See, yeah, you could probably call this x1, y1 if you want. You could probably call this x2, y2 if you want.
X2 minus X1.
Exactly right, that's it. Caleb, and if you want to find the distance between 2 points, you just subtract.
Yes, sir.
So the difference between 2 and 7 is just 5. So like if you wanted to figure that out, it'll be x2 minus x1. So this is just simply x2 minus x1, right?
And two.
And what do you think the next one will be?
2.
So be careful. So like watch, that would correspond to this and this. So how would you find
Y2 minus Y1.
exactly? And Serena, you probably noticed that we are trying to figure out the length of the hypotenuse.
Yes, sir.
Right. So recall from Pythagoras' theorem. This is what Pythagoras' theorem says. So you could call this A, you could call this B, and you could call this C. Pythagoras' theorem says that the hypotenuse squared is equal to the sum of the other two sides squared. So A squared is equal to B squared plus C squared. So Caleb, if you apply that same concept over here, right? And let me just call this thing over here the line, length of the line. One second. Right. So this over here is the length of the line. Length of the line. All right, so Caleb, wait, one more thing. So Caleb, if you wanted to find for A, right? A is over here you have A squared. How would you actually find for A? If it's A squared, and I want to find for A, what would you have to do on both sides?
Divide by 2.
No, no, not divide by two. What is the opposite of squaring something? Do you know what the opposite of squaring something is?
Square root.
Yes. So you would find the square roots on both sides to get rid of the square. And so the square here and here gonna cancel off. So that's just gonna leave you with A. So A is just simply going to be the square root
B
of
plus C.
B squared plus C squared. Now, I want you to ask yourself, doesn't that look very similar to this? It,
Yes.
it, it should, right? And let's understand how that makes sense. Remember, I told you that B and C are just the other sides. So, Caleb, if I wanted to find the lengths of the sides here, wouldn't I have to say x2 minus x1? In this case, it would be 7 minus 2.
Yes, sir.
And over here, that would have to be y2 minus y1, which is
Yeah.
2. Wait, I labeled it bad. This was to be y2.
4 minus 2.
Exactly, 4 minus 2. Excellent. So you could see that this come like B, and this come like C. So if
Yeah.
I want to find the length of the line, it is just the square root of the B term squared, which is the B term, and plus the C term squared.
Yes, sir.
Serena, can you see how it's a direct application of Pythagoras theorem?
Yes, sir.
Great. And I've shown all of these things because if you forget it in the exam, you could derive it. It's not the end of the world. So take a screenshot of this. Wait, wait. And I'll make a little note here. This comes from Pythagoras theorem. Yes, so I'll take a screenshot of that. And before I go, I want to show you all some things for our circle. I think it's fair that we start something for our circle.
A screenshot or two.
Okay, Serena, what about you?
Let's see.
You have it?
Yes, sir.
Okay, cool. Give me a second. Right. Let's move on to some art maths quickly. So circles. Just remind my guys, what is the equation of a line? What is the equation of a line?
Y equals mx plus c.
What are the two main things about a line?
The
The
gradient and the
gradient.
y-axis.
Yeah, the gradient and the y-intercept. Now for a circle, the main things are going to be the radius and the center of the circle. That's going to be the main things. So if you have a circle here, the center is going to be given by minus f comma minus g, right? This over here, I think we could all see that this is the radius. And we would call that sometimes, we would sometimes call that the normal. Okay, is everybody with me? So like, I know this might be a bit weird, like you see in F and G, but can we understand that this is our point? This is the center, the circle? Yeah, that's the center.
Yes, sir.
Okay, so that's the center, and this is the radius because it's from the center to our what? It's from the center to a point on the. Tell me, Caleb. This is our point. What?
The outside, sir?
I was looking for the proper name. Circumference. This is the circumference. This outer perimeter here. That is
Yes.
circumference. This is the circumference. Cool. And if I have a line that touches the circle at one point, what would you call that? Does anybody know? Does anybody know? Caleb or Serena? That's green line. It's true. Do any of you guys know what that would be?
Yeah, sir.
Okay. That, my friends, is a tangent. Call that a tangent. So give me a second. My Apple Pencil is playing up. Yeah. So let's examine what we've discussed so far. I said that you need to know what the center of the circle is. It's given by minus f comma minus g. You'll see what I mean by that shortly. This is the radius because it's from the center of the circle to the point on the circumference. So any point on the circumference, once it's connected to the center, that is going to be the radius. Right? So this is the radius. It's sometimes also called the normal. Now, if you have a line outside of the circle that touches the circumference at one point, it's called a tangent. It effectively grazes the circle. And you see this? This is a point that is on the circle itself. And that would be given by x comma y, because we know our point is just x comma y. Anything crazy so far? Or like, Serena, you okay with that so far?
Great, that's it.
All right. Caleb, you okay with the radius, the circumference, and the tangent?
Yes, sir.
Now, a very important thing about the tangent is that the tangent touches the circle at one point.
Yes.
That's the most important thing. So I'll make a note about that. Because some of you guys will forget that. Right? Touches the circle. At one point. Nice. Would this be a tangent?
No, sir.
No, sir.
No, that would actually be something called a secant. That's a secant. As a tangent. So let's review the main forms for a circle. So let's look at the equations for a circle. You know how you have equations for lines? Well, you have equations for circles. Right? Equations for a circle. Right, so we're starting off with the general form of a circle. So the general form of a circle looks like this. It is x squared plus y squared plus 2fx plus 2gy plus c is equal to 0. Don't worry, you'll remember it over time. You'll remember it over time. Serena, weren't you there for the form 4 maths
Yes,
class
sir.
when you was doing functions, reviewing it?
Yes, sir.
Do you remember the vertical line test? Or not?
Oh, wait. No, I wasn't here.
All right, so
I watched the video, but I didn't know it was on.
okay. So the vertical line test is used to see if you have one solution for the x value or multiple. Think about it like this, right? If I have a line here, let me just say x is 5. When x is 5, if I draw a vertical line, wouldn't it cut the graph at some point?
Yes, sir.
Yeah, so that would tell me when x is equal to 5, I'm getting a y value of whatever. Let me just say 9. Understand?
Yes, sir.
But at any point in time, the x value will only give me one y value. Make sense?
Yes,
What?
sir.
No matter where you draw the vertical line, you're just gonna get one output. Right? And that's how a function behaves. A function takes in an input and gives you one output. But over here now, I want you to pay attention to something. If you do the vertical line test for a circle now, let me just say when x is equal to 3. Notice it cutting the circle at 2 points.
Yes, sir.
But that don't make sense because it is telling us that when x is equal to 3, I'm getting 2 values for y. But that don't make sense. If you buy ingredients to make a chocolate cake and they put it in the oven, and you could only get a chocolate cake.
Yes, sir.
So if I put 3 into the function, I'm only supposed to get one y value out. Again, if you buy ingredients to make a chocolate cake, Caleb, when you pull it out of the oven, could that be a vanilla cake?
Nah,
No, so like at any point in time, a function is supposed to give you one output. So, Serena,
Yes, sir.
as such, the vertical line test, it tests that for us. So if you draw a vertical line, you see it cut in the circle at 2 points, then therefore, this would not be a function. That would not be a function. That wouldn't be a function. And the vertical line test, it tests that. Because a function only has one output. If it has more than one output for the same value for x, it's now a function. Caleb, you uniform for maths class or not?
where is it, sir?
Are you uniform for maths class?
Nah, sir.
Now, okay. You might know what I'm talking about them, but yeah, might not. All right. Let me continue. Let me continue. So this is a general form of a circle you need to be acquainted with. And there's one other form you need to be acquainted with as well. That is called the standard form of a circle. Now the standard form of a circle looks like this. So it is x plus f squared plus y plus g squared is equal to r squared. Right. Now, Serena, if I were to expand the standard form, what do you think I'll end up with? Serena?
Could you repeat that, sir?
If I were to expand and simplify the standard form, what do you think I'll end up with?
No,
Say that again?
I'm not sure.
Think about it, right? If you were to expand this, you would end up with x squared plus 2fx plus f
Um,
squared, and you would end up with y squared plus 2gy plus g squared. And if you move across the r squared, it'll be equal to 0. And if you rearrange it, you could put it in the form x squared plus y squared plus 2fx plus 2gy, right? And if you group in all the constant terms together, that's going to be plus, that would be f squared plus g squared minus r squared. And that would just correspond to the c part. Yeah?
yes, sir.
So like, Caleb, if you expand the standard form, you're going to get the general form. So I'll make a note about that. If you expand the standard form, you will get back the general form. And some equations that you need to be familiar with, R. So how would you find for R? R would be square root of f squared plus g squared minus c squared. And Serena, you're probably saying, so where the heck you get that from? Remember when we expand this out, right? We ended up with f squared plus g squared minus r squared, and that was equal to 0.
Yes, sir. Yes,
All
sir.
right. All of those, do any of those have x and y in it?
Mm-hmm.
No. So all of those are constant terms. That would correspond to the c term. So long story short, c would be equal to f squared plus g squared minus r squared. Yeah or no?
Yes, sir.
All right. So I make a mistake here. It's not supposed to be squared. Yeah. As you can see, it will work out because over here you'll end up, if you expand this, you'll end up with f squared plus g squared. And if you move across the r squared, it'll be minus r squared, and that'll be equal to 0. So this entire thing, these are constant terms. Caleb, do you think you understand why I'm calling these constant terms or not?
Nah, sir.
All right. You see an x or a y anywhere over there?
Nah, sir.
If you do have an x or you do have a y, then it's a constant term. It's a number.
Yes, sir.
So like this would correspond to this, the c term. So c is actually equal to f squared plus g squared minus r squared. And if you were to make r the subject of the formula, this is what would happen. So if I move across r squared here, that's going to be r squared. And if I move across the c, that's going to turn to f squared plus g squared minus c. Serena, let me know if you understand that.
Yes, sir.
And if I want to find for r now, what how to do? So I have r squared is equal to f squared plus g squared minus c. And I want to find for r. What would I do next to find for r?
It would be R is equal to the square root of f squared plus g squared minus c.
Yep, excellent. That's it. Right? Um, don't worry, Caleb. In the next class, I'll go it over. I'll take my time and I'll go it over. Don't worry. And you could, and if you have 2 points, if you have, if you have the center and a point on the circumference, which formula do you think you could use? So here what I'm saying, guys, if you have a circle, right? If you have a circle and you have a point in the center and you have a point at the circumference, what formula you think you could use to find the length of the radius? I promise you it's something we covered in class today. So Caleb, you there?
Yes, sir.
Caleb, if I have a point at the center and a point on the circumference, if I find the length of this line, that will give me the length of the what?
Circle.
No, the length of the radius. Remember, the line from the center of the circle to the circumference is the radius.
Yes, sir.
Is there a formula? Is there a formula that we know we could use to find the length of a line given 2 points?
X plus x1 plus x2.
No. This formula I'm talking about. So if you have 2 points, you can use the length of line formula. And to use our formula, you need to have 2 points.
Yes, sir.
So like what I say now is if you have a point at the center and you have a point at the circumference, you can just use the length formula and you'll get the radius. So that will just be x2 minus x1 squared plus y2 minus y1 squared.
Yes.
Right. So let me just so that's essentially it. That's essentially all you have to know for circles. That's literally all you have to know for circles. You also need to know equation of tangent to a circle, but that's easy. We've covered things like that. So let me give you all some homework now. Cool. So there's this. Wasting virtual paper. My bad, my bad. Put this over here. Cool. So yeah, that's all your homework there. Right. So Caleb, now you should know what the equation of a line is. You should have that locked in by now. So Caleb, if I ask you where's the equation of a line, we're gonna tell me.
x2 minus x1
Nah,
squared.
nah, that's not the equation of a line. Wait tell me there's the length of a line. Equation of a line.
Oh,
Okay? It's the equation of a line. equation of our line. Right, so you have some work to do. Remember, the equation of our line is y is equal to mx plus c. So,
Oh, down okay.
right, so this, let me just label it. This is the equation of our line. And you need to know this equation of a line. Cool. So I'll send these notes, and yeah, see you guys in the next class. Later, everybody. Have a good night.
It's
Later.